This tutorial will compare visual scripting using Bolt and programming using C#. First, I'll explain what's going on in a Unity C# script. Then we'll create a Bolt graph with some basic functionality. For each node and variable we add in Bolt, we'll create its equivalent code in C#. Bolt is a free visual scripting asset and has recently been bought by Unity. Unity intend to use Bolt as their standard tool for visual scripting in Unity from now on. If you are unfamiliar with the basics of using the Unity editor, including using game objects and components, or you are unfamiliar with Bolt, including using the graph and nodes, then please check out the official Unity tutorials on those subjects before watching this video. No programming experience is needed for this tutorial. First, let's compare a Bolt graph to a C# script. I'll create a bare minimum Bolt graph with a start event node connected to a print node. I'll enter the message hello Bolt into the print node. Let's open the console window and run the game to see our message. Now let's move on to recreating this print message in C# code. First, I'll create a C# script in the project window. I'll name the script Hello C#. The name of the script has no spaces and capitalized letters for each new word in the name. This is the default way programmers name their scripts. Also, only use a letter at the start of the name, no numbers, etc. The exception here is that you can use an underscore character. You can put numbers at any other point in the name, but no spaces or other symbols. If I open my Explorer window to view the file, you'll see that a C# script is just a text file. They can be opened in any text editor, like Notepad. The C# programming language is a type of compiled language, which means that another program called a compiler must gather up all of the C# text files containing the code, read that code, and convert it into computer-readable data. This process is more complicated than I just described, but this is just a broad explanation for the purposes of this video. For our C# scripts, the Unity editor will compile the scripts for us. So let's open this script. I'll be using Microsoft Visual Studio to edit this code. Please note I have set my color scheme to my personal preference of dark mode. However, the code coloring is the same for light and dark mode, only the basic text is light or dark according to the mode. At the top of Visual Studio, you can see a tab with the name of our C# script file. Note the name includes the file extension .cs, short for C#. The panel below the tab contains our C# code. If this looks very alien to you, focus on the word start here. This line of code containing the word start is our event function, the same as the start event node in Bolt. We will use this soon to print our message. First, let's explore this C# script word by word, line by line, and find out what's going on here. So, why are some of these words and symbols blue, green, or white? This is our code editor, Visual Studio, highlighting important words in the C# programming language. These blue words are called reserved words, which are used by C# to do specific tasks or provide specific functionality. Green words are for named items, like the name of our script. When writing code, the words need to have the same uppercase and lowercase usage as shown in this code. Please take note of the notes provided here on the left whilst I go through this code. The blue word using at the top here means we are using another library of code from outside of our script. Each of these lines requires a semicolon, which tells our compiler this is the end of a code statement or instruction. We will see more semicolons used in future code. The library of code we are using here is called system.collections. Notice that the color of the text is dimmed on this line and the line below compared to the third line. This is Visual Studio telling us that we are not actually using any code from the system.collection or system.collection.generic libraries. We can actually delete these lines of code as we are not going to use any of their functionality here. This last line of code is using the library Unity engine. The Unity engine code library is our way to use C# code with all of the features of our Unity game. Here is the documentation website for the Unity Scripting API. API stands for Application Programming Interface. Notice I'm in the same version of my scripting API as my Unity project. Some of the code base can be different between versions of Unity, so do check this. In the left menu, we can see a link to the documentation for the Unity Engine library, which is used to create our games. Notice the other library called Unity Editor. This is a scripting API for creating custom editor tools in Unity. The Bolt system and editor windows were created using the Unity Editor library. The Unity library is for Dots, a new C# based scripting system that is currently in development. We are not covering Dots or editor scripting in these tutorials. So back to our code. The green writing with 2 slashes at the beginning is a code comment. This text is not read by the C# compiler, it is for making notes and documenting the code. This text is telling us that the start method runs before the update method below. If you have experience with Bolt, you probably knew this already. Comments are very useful to leave notes so you don't forget what's going on 6 months later. They are also great for working in a team and letting other programmers know what's going on with your code when they read it. This first top line of our code has 2 blue words. These are reserved words in C#. And it also has 2 green words separated by this colon. Also, note the order in which these words appear. This is important too. This line here is called a declaration. It is declaring that this C# script contains a public class which is named Hello C#. This class is using or inheriting code from another class named MonoBehaviour. So what does public mean? The reserved word public in C# means to gain access. In programming terms, public is a type of accessor. There are 2 commonly used accessors, public and private. In this code, we are stating that this class can be accessed by other classes by using the word public. When creating a script to use with Unity, the class should always be public. So, what is a class? A class is a container for a set of fields or properties and methods or functions. You may know fields in Bolt, they are called variables, and methods in Bolt are called events. When we add a script to a game object in the Unity editor, we are creating an instance of that class. This is a similar way to how prefabs create game object instances when dragged into a scene from our project view. The class file is copied or instantiated as a component when we add it to a game object. We're able to do this in the Unity editor because of the MonoBehaviour part of our code. We'll get to that soon. This copy or instance of our class has its own set of fields and methods. Fields are settings or values used by the methods in your class. Fields are also often called variables in Bolt. So if we look at any component, you'll see the fields belonging to that component or instance of that class. So we have a transform component, we have a transform class, and here are the fields for it. You can have numbers, letters, words, tick boxes, other components, game objects. You've seen these things quite often, so we can go to the hierarchy and see an example of many different types of components here with all sorts of different types of fields. Methods are sets of instructions. The top line of our script, the using line, is an example of an instruction ended with a semicolon. Our script has two methods, start and update. We know that the start method does the same thing as our start node does in Bolt. We will look at properties and methods in more detail soon. So why does Visual Studio display the name of our class Hello C# in green? This is because our class is a blueprint for creating Hello C# components on our game objects. We are declaring that Hello C# is a type of object we can create, thus reserving that word in our code base. The compiled game code knows about this class, so we can use this class by this name in other classes. The green text is Visual Studio telling us that our game project knows about our Hello C# class. So once again, this is because our name is after the word class in our declaration. Also note that this is our custom name for this script that we can choose. The name of the class must also match the name of the file, excluding the .cs part, or Unity will not be able to use our script as a component. So what's this colon symbol for after the Hello C# name of our class? This is C#'s way of letting us use another class or other type of construct inside of the code of our class. We are using or inheriting a class called MonoBehaviour here. Note the spelling and uppercase letters used to separate the two words. MonoBehaviour is a class inside of the Unity Engine library. Here is the live documentation for MonoBehaviour. The page shows a list of some of the methods we can use from the MonoBehaviour class. Some of them might look familiar if you have some experience with Bolt. So now we know what a declaration for our class is, let's look at the content of our class. So first, there's an opening curly brace to our class. If I select it here, if you look to the bottom of our class here, you'll see there's a matching closing curly brace, and you'll see that they're highlighted in Visual Studio for us whenever I select the beginning or the end of each of those curly braces. These two braces contain the fields or variables and methods or events of our class. Notice how all of the text within these curly braces is indented about 4 spaces in from the other code. This is a way for programmers to quickly separate parts of the code by eye. Curly braces are a core part of how C# code is organized. If you notice, there are also 2 more sets of curly braces within our outer ones. If I enter a comment, within one of these sets of braces, it is indented 4 spaces from the curly braces. Notice that our start word is above this set of curly braces. In the same way that the braces under our class declaration contain all of the properties and methods belonging to our class, this set of braces contain all of the code instructions for our start method. Methods in C# are also often called functions. Methods can optionally have an accessor at the beginning, a private or public, but one is not included here in the default Unity script setup. When a method has no accessor, a public or private is missing, the method defaults to being a private method. So this currently is the same as typing in private, like so, at the beginning of the method. So to explicitly make a method public, you have to type in the word public here in order to ensure that it is indeed public. So what does the word void mean in C#? Void is a reserved word in Unity meaning nothing, as in literally the void of space, nothing. Like classes, methods have a declaration, an order of words to specify how to use them. The void part of our method declaration is called the return type. When a method is used in C#, you can optionally return something from it, like a number or a string of text. So both our start and update methods return void or nothing. So what are these brackets for? Methods have outputs, as we saw with the void return part at the beginning of the declaration, but they also have inputs, or values that can be included in these brackets and used within the code of the method. These inputs are called parameters. For example, a method to add two numbers would look like this. Here's our custom add method called add. Here's the name, and we have a number or an integer, a whole number, as a return type instead of void. And notice that inside of the brackets here we have our two parameters. Now these two parameters are separated by a comma, but do note that the parameters consist of two parts. We have the type of parameter, which is an int, same as this one, which is a whole number, and then we have the name for the parameter. So I have an integer called A and an integer called B. The code to do the calculation is of course within these curly braces. Note that if our return type is not void, as in here it's an integer, then we are required to return a value or we will get an error. This is what this red line is showing. It's an error. If I mouse over here, it says all code paths must return a value, or not all code paths return a value. So what this is telling us is that this needs to return a value. The code path, it refers to, as Unity or any code programming language goes, the code is gone through line by line by the computer to calculate what it needs to do. And the code path is where it is at the time. So where it says code path here, it means that when the code gets to this point, then it's going to get an error. So let's fix this just quickly. We're going to cover this more in a later video, but I just want to finish this off so you know why this error is here and how to fix it. So you need to enter the word return, and then you need to return something of the type int. So what I'm going to do is actually add these two together just to complete this method. So what I'm going to do is refer to A, the first parameter here, then I'm going to put a plus symbol and then the letter B for this parameter here, and then I'm going to finish it off with a semicolon, because as you remember this is a instruction and we finish those with a semicolon. So that is how to write a method with parameters and a return type that isn't void, that is an actual number or an actual value, and how to actually return that properly using the return notation here. We'll cover this a bit more in later tutorials. So I'll leave this on the screen and we'll carry on with our debug printout. So now we have some idea of what these words and symbols mean. Let's write a line of code to output our message. So I'm going to place my typing cursor inside of my start method here within the curly braces on the first line here to start an instruction. So I'm going to type the letter P, and you see the first option here is print, which is what we're explaining here. This is the thing that we're looking for. So this pop-up window is really handy for typing out code, because you can type something in and Visual Studio will give you anything that's within context of that code at the time. So this print statement is part of MonoBehaviour, and it's available to me to use inside of methods from classes that extend from MonoBehaviour. So let's press enter, and now I'm going to type a left bracket. So you notice that Visual Studio has completed this for me and added the other bracket and left my typing cursor within the two brackets, allowing me to type stuff out in the print statement without typing my other bracket. So what I'm going to do is type in a double quote, and notice it does the same thing here, adds a double quote on the other side of my cursor, allowing me to type stuff within the quote and the brackets. So I'm going to type hello C#, and then I'm going to place my typing cursor at the end of the line, and I'm going to add a semicolon like so, because this is an instruction and that's what we do at the end of instructions in C#. So we've just used the print method, which is part of the MonoBehaviour class. Notice how we use the method name print, then use the brackets to give the print method some input information. We give the print method a string of text, or some words together within our two double quotes. A string of text is a type of value we can use in Unity. You will have to use them several times in Bolt, I would imagine. For example, we used them in our print node earlier. So print and start and update are all methods from the MonoBehaviour class, but you can see they're used quite differently here. See, we're using this print method to print something out. However, the start and update methods, we seem to have created methods, but they're used within MonoBehaviour. So what's going on here is that MonoBehaviour has something called hooks, or we can call them implementations, where they have a start method and an update method that we can what's called override or implement, which will add or change existing functionality of these methods in the MonoBehaviour class. This is part of something called inheritance, where we can inherit behavior and functionality from another class. And the print method here is an example of just using a method, not inheriting or changing it, just simply using the method as intended. So let's go back to Unity and run our script. What I'll do is I'll comment this out just so you know that we're not using this code in here right now. We'll do a little bonus thing in a minute and print out a couple of numbers that we can add together in the print statement, but for now what I'm going to do is press this button here. It says comment out the selected lines, so it's going to apply one of these comments to a class so it's not visible to our code base. So I'm going to click that button. You see it adds in these two slashes to each of the lines are highlighted, just like this comment. This means that this code is now invisible from the code base. It's not going to be compiled. And then I'm going to save my file here to make sure that the star is not visible anymore from here. We'll go back to Unity and let's start the game. So what I'll do is I'll select my car C#, make sure that's there. I will turn off my Bolt car for the moment so we don't get any output from here saying hello world. And what we'll do is start the game and should see an output from our car C#. So hello C#. So there's our output from the car, our hello C# class. And that is what this print statement is doing within the start method. So what happens if I put the print statement inside of the update loop? Obviously we get a bunch of readouts here, just like we would do if we did this in Bolt. So now we get tons of hello C# because it's in the update loop, just the same as it would be if we had it a update event here and then put this code in there. So now we know how to call this method. Let's use our custom add method we made here to output a value here. So I'm going to put this print in the start method, so it only appears once when we play the game. And then I'm going to delete this text, and what I'll do is uncomment this. So next to this comment button where I commented out this code earlier, the button next to it will uncomment it. It says uncomment the selected lines, so I'll click that, and there you go, it's uncommented it, and now this is visible to our code base. So now I'm going to use this add method inside of this print method. So we're calling a method inside of another method as a parameter. Crazy stuff. So what I'm going to do is just put the word add, then I'm going to put a left bracket here, and I'm going to put a couple of numbers separated by commas, by a comma. So I'm going to put 2, and then a comma, and then a 2. And then I'm going to close my brackets. So I'll just separate this out with a couple of lines, spaces here. So what's going on here is this print bracket here, if I click this side of it, you'll see that it lights up the end bracket there. And then inside of these two brackets we have this add method here, and if I click here you can see it highlights the start and end bracket for add. So always keep an eye on these brackets, same as the braces, they need to match each other. So if you select them at the end of it, you'll be able to see where the other end of it is, depending on which end you are. So with that being said, let's test our add method and see if we get the answer 4. I'm going to save my file, see that, and then I'm going to go back to Unity and we'll press play and see our output here in the console window. And there we go, we get our answer of 4. So 2 plus 2. There we go. So what's going on there is this add method, I'm giving it 2 numbers, so this number and this number, separated by a comma. So if we look at the declaration for our add method, within the brackets once again we have an integer called a, and separated by a comma with an integer called b. So this 2 and this 2 is the value of a and b when we call this method. So every time we call the method we're setting these to specific values here. So once again we'll cover this a little bit more in a later tutorial. It's a bit more advanced for now, but I just wanted to show you how we would implement that. So now we know what's going on with our start method in C# and our start node in Bolt. Let's take it a step further. So I'll switch back on our car bolt here, and then what we'll do is we'll delete this print message and our string from our start node in the Bolt graph. Let's add a variable to our flow machine for our Bolt car. We'll name it car color. Notice the lowercase first letter and the uppercase second letter for the next word. So I'll click the add here, and then I'll set the type to color in here, color in Unity Engine. So now let's do the same thing in C# and create a car color variable or field. Just like a class or method, declaring a field requires the words to be in the correct order. Fields start with an optional accessor, that's a public or private. Fields are often put at the top of a class before the methods. So what I'm going to do is place my cursor here at the opening brace of the class declaration and enter a space to enter our first field in here. Hit the letter P and see if it comes up in your options. So here is public, so I can select it from here. Notice public is lowercase, all lowercase. Make sure there's a space, then type the letter C-O-L, and here's color right down the bottom. I'm going to click that and hit enter. Color is another class in Unity. This is why the text is green like our class name. And in fact we can see a word struct Unity Engine.color. So you can see color is part of the Unity Engine library here in the help text right there. The color class is used to define a color in RGB format with an optional alpha or transparency value. Next, put a space and enter the name for our field car color. Similar to our class name, we can't have any spaces or other symbols in our field names, nor start them with a number. Now let's finish our declaration of our field with a semicolon, and we'll put another space under there to keep it separate from our methods. We have just declared a public field of the color type named car color, all one word. Note that declaring properties are kinds of instructions, hence the need to include a semicolon at the end. I'm going to save my file, and then let's take a look at our color field in the Unity editor. So here it is, a color field in our custom script component. Notice that this color defaults to black, whereas if we go to Bolt, the default value for our color is white. But if we open this up, you can see that we have our color pull down, and the same with our color for our car in our Bolt script as well. So what we'll do is we'll get hold of our Bolt car's MeshRenderer component here, and then we'll apply our color to it later on. So we'll add another variable up here to get our car's MeshRenderer component. Note that the component we're getting is not actually on this game object. If I go inside here, it's actually inside of this body game object as a child of our Bolt car here. So let's add a variable here called car renderer. Set it to type of MeshRenderer. So here we are, MeshRenderer in Unity Engine. This is a MeshRenderer component. In the hierarchy, drag the body game object up to our variable here to set its value to body MeshRenderer. So if we click here, we can see we've got the MeshRenderer from this separate game object here. Now let's create this in C# code. So let's make some space below our car color here, and we'll create a public field for our MeshRenderer component here. Just like our car color, we will need to edit the field in the Unity editor, so our field here needs to start with a public accessor. So now put a space and type in MeshRenderer, all one word. So you can see here that my option comes up for MeshRenderer. It says Unity Engine.MeshRenderer. So MeshRenderer is part of the Unity Engine library as well. So, and also notice that MeshRenderer starts with a capital M and separates the two words with a capital R. So I'm going to type enter here. And of course the text for MeshRenderer is green, the same as Hello C# and MonoBehaviour, indicating that this is a class. Next, put a space, and let's put a name for our field here, car renderer. And of course, we end this line of code with a semicolon. So one thing I would like to point out is the difference between these two fields is that this MeshRenderer, as I said, is the same shade of green, kind of turquoise, as these two words here. So it's the same type of thing, a class, as our Hello C#, which is a class, and MonoBehaviour, which is a class. But I don't know if you can notice, but this color word here is not actually the same shade of green. It's a slightly more greeny green, slightly less turquoise, but if I mouse over it, you can see it says struct Unity Engine.color, whereas down here it says class Unity Engine.MeshRenderer. So this is not a type of class, it's a type of struct. So you remember I said that we can inherit from different types of classes and other constructs. Well, a struct is another type of construct opposed to a class. So if I were to create one of these structs, we would actually call it a struct where we called it a class here. So we would replace this with the word struct. So that is another type of construct, and you can see that Visual Studio colors it slightly differently for us to just tell us that it's a type of struct and not a class. With this field type of MeshRenderer, the value that we use is actually called a reference. So we will be referencing a component on another game object, but specifically we're referencing a component which is a class or instance of a class outside of this code here, unlike the color struct here, which is actually a instance of a class, kind of like its own component within our class. So of course a mesh renderer is a separate component, so this is known as a reference. So we're referencing a renderer on, in this case, another component or another game object, but we can actually reference a component on the game object, the same game object that this class is on. So in our bulk graph for our car renderer, the same type of variable as we've got in our C# script, if I click on the value here, it actually goes to another game object and it's referencing this mesh renderer component, which is outside of our bulk graph. Referenced fields, like other components, are empty until we set them, like in our Unity editor. Unlike our color field, which will always have a default value, that's part of the functionality of a struct. And if it's not set, it will just set to a default color. So it sets itself to black for us in C# and white in Bolt. C# uses the reserved word null to mean empty values. So if we didn't set this mesh renderer, it would be by default set to null, represented like this. Or if I typed in, it's the same as this. Until we set that in the editor, that's what this value will be. So let's go back to Unity and set up our mesh renderer field, car renderer, in the inspector. I'm going to save my file and go back to Unity. And then we'll go to our car C#. So here's our car C# component. So we got our color here, and then we got our car renderer down the bottom. Now something to point out with the presentation of items in the Unity inspector is that Unity will detect these uppercase letters in your names and then apply them to the names in here. So you can see car color has an uppercase C and a space between color, whereas it's spelt differently here. So this is just Unity's inspector pulling that name out and then giving it capital letters and separating it where it finds a capital letter. So here's our car renderer. So just like our car bolt, if I select that here, we have our variable set up for car renderer. We have the game object body inside of car bolt that we're referencing for this value. So let's do the same thing for our C# script. What I'm going to do is for my car C# here, my separate game object, I've got another body here. I'm going to drag that into our car renderer here, and it says the same thing as our bolt variable, body mesh renderer. So if I actually undo this again, what I'll do is I'll click the circle here and I'll set this to none. You can see car renderer says none. So in code, this means null. So it says none in terms of I'm not referencing a mesh renderer. There's nothing of that here. It says none, which means null in C#. So I'm going to put that back in there. So let's go back to Bolt and apply the car color to our car. So I'm going to select Bolt here. Then I'm going to drag in this car renderer variable into my graph. So now let's just do this in C#. What I'll do is I'll delete this text here. So we're not going to use this print anymore. And I will just cover this over into comments using my comment out the selected lines button here. So we're not using this code or referring to it. It's not compiled or anything. Then what I'm going to do is we're going to do this get variable car renderer in C#. So how would we get a variable in C#? Well, it's actually very, very simple. It's this word here. So the name for our variable, I just copy that and paste it into my start method here. Now notice I haven't in bulk connected this up to it yet. So we're going to use it later and see how that connects up. But for the moment, this is the same as this. So next we want to get the material from our car renderer here and then change its color. We're going to apply our car color to it. So in Bolt we drag off a connection here, and I'm going to type in get material to get our material, and we want to pick renderer get material. So this will get it from our mesh renderer component here, renderer.getMaterial. So I'm going to click that. And there we go. So now how do we do this in C#? So our car renderer has a material field on it. So let's take a look firstly at the component itself. So in MeshRenderer we have materials and we have a set of materials here. So we can get a material from that. This particular method on renderer will actually just get the first material here. So even though there's a list of them, when you get material, it's like, oh, just get the first one from this list. And we can do the same thing here. So in order to access a field within a component or other type of construct within C#, we use the full stop symbol or dot symbol. In C# terms, this is known as the dot operator. And you can see that our options now have opened up to give us the available fields and methods or variables and events belonging to our MeshRenderer component. And in particular, we can access the settings for our body component here because we've dragged it in as a field type here. So notice that we dragged in our component to this car renderer field in here, and now we're accessing that particular component's fields and methods inside of here using the dot operator or full stop symbol here. So just like you saw this get variable and then the name of the variable in Bolt, and we just used the name of the variable itself or the field in C# here, we can do the same thing for this. So it says get material, whereas there's actually a field on here called just material. So I type dot and then I just start typing out the word material. You can see here it is. So this, if I double click and select it, this is the same as renderer.getMaterial, is to get the material field from our MeshRenderer class or component here. So next, let's actually change the color of our car's material. So we've got our car's renderer, then we've got the material from the renderer, and then we have a method on the material to change the color. So let's do that. I'm going to drag off a connection here, and I'm going to type in set color. Now we want a specific version of this so we can see what's going on. So I'm going to select this one, material set color, and then it's got these brackets with name, comma, value. So I want this one here. Okay, material set color, name, comma, value within brackets. So we can see that we got our name down here and our value down here. Inside of the name field, I'm going to set the name to underscore color. That's color with a capital C here. So this will refer to the color inside of our material, which is a field or property or variable within the material class. So let's do the same thing in C#. So what we have to do is with our material here in C#, just like we've got this get material, we've got the name here. So we need to add another dot and then get this set color. So I'm going to add in a dot here, and you can see already we've got a color at the top. We want the set color, but you can see that there's already options to do with material here. So let's scroll down, and here's our set color method here. So it says void material.setColor, string name with a comma, color value. So this is saying that our material here, which belongs to the material class, if you can see from your screen here, it's a green color, the same as the green color of our MeshRenderer, our name for our class, MonoBehaviour. It's one of these. It's definitely a class. So this is a class with a method called setColor on it. And setColor has two parameters or input values. It also has a void, which means it doesn't return any value. It just sets these two parameters within the event or method. So our two parameters here are a string name separated by a comma, and then we have a color value. So these are our two types of parameters, a string and a color. So let's select that by double clicking or pressing enter. Now we need to enter our brackets, as setColor is a method the same as start or update. In fact, I'm going to delete this and show you how you can tell the difference between these. So I'm going to delete these and reinsert the full stop here. So in our list here, you can see that setColor has this small purple cube icon here. This is referring to a method, whereas you see these other values like name, pass count and things like that. These are fields. They have a little spanner symbol here. So when you're looking at these lists, do look at these symbols that tell you what kind of thing you're dealing with, whether it's a field or a method or something else. So let's set this up quickly again. I'm going to put a dot and then set color here. So once again, I'm going to enter my left bracket and it's going to complete it for me. So you can see down here that we have our two parameters here. And if you see these, if you can see this on your screen, we've got an up arrow and a down arrow here, and it says 1 of 2. So what this means is there's two flavors to this method. And what I mean by flavors is that the actual parameters here can be changed to do this method in different ways. This is something that's a bit more advanced we're not going to cover here, but just know that methods can sometimes have different implementations, meaning that they've changed up some of the parameters here to do different things with the method. So if I'm going to click the down arrow here, so this is the one we want. We have a void Material.SetColor string name parameter and string color value parameter. So this is the one that we want. You remember that we have this down here in our bolt script where we have the name and the value. Well, this is what they are, a string name. So you can see we entered in underscore color here. Actually, you can see in bolt that strings or strings of text are actually in orange here. And then you can see this color value here in bolt is actually this value here where it's got a type of color with the color icon here. So that being said, what we'll do is we'll enter in our name the same as our bolt script here. So I'm going to put in a double quote and then it's going to put a double quote on the other side for me. And then I'm going to enter underscore color with a capital C, exactly the same as our bolt script here. And then what I'm going to do is move my cursor after the second double quote here and put a comma in. So this will be my next parameter that I'm going to enter here. So this parameter is going to be a color, and that is the same type of class as our car color here. You can see it's color and it's even got the same shade of green and everything. So what I'm going to do is copy the car color name inside of here, like so. And then I'm going to finish off this line of code with a semicolon. So this is it. So let's take a look at this in Bolt. So in Bolt, we've set up our car renderer to get our car's material, and then we've applied a set color node to it to change the color. And what we need to do is just complete this setup to match our C# setup. At the moment, compared to C#, our Bolt setup will be all of this, but minus these two settings. So it would be kind of like that, matching what we're doing in Bolt at the moment, where we're calling this set color. We've given it one value, so it's got some default stuff in there, but we haven't set anything in there. So I'm just going to go out to edit, and then I'm going to click undo to undo those changes in my code. So what we need to do now in Bolt is just finish this section that we've done in C#. So we've done this part actually. We've got this first parameter filled up. If I mouse over here, so it's a set color string name, and that is our name of the thing on material, the material that we're going to set. So we have actually done that in Bolt here, where we've got our underscore color here. Notice that Bolt has a default value of white set here. So if I ran this, then it would just set the car to the same as what it is, but we want to change it to a custom value. So in C# we have actually used our car color field here as the second parameter in set color. If we go back to Bolt, you can see that this last value here is our car color. So let's set this up the same as we've set up in C#. I'm going to drag in our car color variable here. Then I'm going to connect our node up to the value of our set color here. And then finally, what I'm going to do is set the connect the start event to our set color here. So now you notice that all of our Bolt nodes in our graph are lit up, meaning that they're all going to run. So what I'm going to do is try them one at a time and then we'll compare them to each other. So firstly, let's check our bolt 1 works. What I'm going to do is go to my C# car here and just switch it off in my hierarchy, so we're only getting our output from our car here. Next, I'm going to select my bolt car that we're going to test here, and then I'm going to change my color. So I'll change it to red. So when our game starts up, our car's color or parts of the car should change to red. So let's give that a go. And there we go. So parts of the car changed to red. So this script is working, this bolt script here. We're changing the color of parts of the car. So let's check our C# car and see if that works. So first, I'm going to go back to the script here. I've just noticed that I didn't save the script. There's a small star on this tab, so I'm going to hit Control S, and then I'm going to go back to Unity. So Unity is actually compiling my code there. That's what all of this stuff means. It's actually compiling my code. So now the C# car should be working. So what I'm going to do is switch off the car bolt game object for now, and then switch on the car C# game object. So I'll just go back to the console here, so we're not in any bolt stuff, and then I'm going to change the car color to a blue, like so. And also, like I said before, there is an R, G and B property on the color class, and an optional A, which is alpha or transparency. So you can see that how that works here. Right, so now let's start the game and see if our car turns blue, or parts of our car. So you can see indeed that parts of the car turned blue when we switched on the game. Great, now let's try them both together. So our bolt car should turn red and our C# car should turn blue. There we go, so our bolt car is red and our C# car is blue. So let's discuss what we've learned here. A bolt graph, a flow graph specifically, which is a flow machine component on a game object that uses bolt, is similar to a C# class that implements MonoBehaviour. So these two things, the fact that it's a class that inherits MonoBehaviour, is what makes it similar to a bolt flow machine or flow graph here. The reason being is that we can access these start nodes, update nodes, these event nodes that we can do things in our graph. So you can see that a standard bolt graph comes with a start event. You can have other events as well. So we can have an update. So that the bolt graph will automatically come with one of these as well, but there are many more, so collisions, triggers, things like that. And these things have their exact correlation inside of a C# script. So you can see we got our update here, which is the same as a bolt update, and we have our start event here, or method, which is the same as the start event in bolt. So they are named slightly differently, but they are performing the same things. So next we have variables and properties. So we learned that a variable in bolt is the same as something called a field or property in C#. Standard C# denotes that you should call it a field, as a property is actually something slightly different in C# that's a bit more advanced. So we made two of these fields. We made a color field and we made a MeshRenderer field in C#. And then we made their equivalents in bolt. So you can see that there's similarities between these two things. So firstly, there's a type where we have to set here, and a value which we can set here. And when coding in bolt or using the flow graph, there's actually a great amount of similarity between coding in C#. So this piece of code correlates exactly to this line of code here. And the reason being is that firstly we are getting a variable here which is the same, as I said, as a field. So this get variable command or node in a flow graph is the same as just typing out the variable name. This is the same as get variable in C#, but we're just getting a field. And then the same for get material. This is actually just a property on this renderer here. And So this link between the nodes here correlates to our dot operator here, where we say I want to get this component, and I'm going to put a dot, and then after the dot, it's like I want to get a property of that field. And that's exactly what we're doing here, is we're dragging this off and going, I want to get a property of this field or variable. So you can also see that when we access a method or event inside of a variable or a field, that we also use this dot operator. So the same as like this material has a set color like method or event on it to set the color, we can access that the same way using this dot operator and then the name of the method. And then we can see that this node, this set color node, has these two values here that we can set, and these are the same as these parameters in our method set color here. So you can see we got a name which is orange here, which means it's a string of text, and then you can see here that this orange string of text within these two quotes in the C# version denotes that same piece of text. Then lastly we have this color value here. So we are using our car color here, and we can actually shorthand see these two values. If we just mouse over set color here, you can see these two parameter value types match up exactly with our material set color node in Bolt. So lastly, of course, we have created this variable car color here, and then we're using it within our graph to fill out one of these parameters for our set color node here. And we're doing the exact same thing here, where we've got this field, and then we're using the name of the field to refer to whatever color we set to it, and putting it as our second parameter separated by this comma here into our set color method here to change the color. So next video we're going to fill out this add method here inside of our Bolt graph and see how we make custom events in Bolt, and then how we fulfill that custom event the same way in C#. So I will see you soon.